All right, let's examine first the input-output power relationship of a system. And before we talk about this, I just want to go over what an amplifier looks like in a dB plot. So let's assume I have an amplifier with a gain G. Okay? If I put X in dB, I would get X out plus G. Now we're assuming here that G is in dB and X is in dBm. And if you're not sure why that is, well, in the linear domain, right, it would be the input signal times the small signal gain, right? But if we take if we just take the log of that, you know we would get the log of X plus the log of G, right? And I've ignored the 10 that goes out in front of here, right? So you can see how multiplying in the linear domain, we're just going to add in the log domain, and that's why we use the log domain. So now if I come in with X plus Y, what's the output going to be? Well, it's simply going to be X plus Y plus G. And what we notice is that the output power, or the output power of the amplifier, is P in plus G. This is P in. Okay? So you can see that there's a linear relationship between P in and P out. And most notably, the prefactor here is simply 1. That means if I plot P out, and this is in dBm, P in dBm, what I'm going to do is have a straight line with a slope of 1 with an offset equal to G. So my slope will be 1, right? That's what I have here. If P in goes up by 1, P out goes by 1, and this offset is simply my G. So any linear amplifier that has a power gain of G is just going to have an offset, but its slope is going to be 1. Okay, this is just an important point as we go into the next slides, because you'll see that we'll be assuming different slopes for different components, and as we do the Taylor expansion, we'll also see how this affects the 1 dB compression point. All right, so let's go take another look at a specific example. So as shown you here before, here's your input X, and our output is X plus G. I know it intersects here at 0, but let's just imagine that this is 0 and it has an offset of G here. Okay? And then as I put in my X plus Y, all it does is it moves up, as I showed on the previous slide. And the question is, what is the slope? We know that answer. It's simply 1. But at some point, as the power increases, the amplifier stops being linear. And we say that the output starts to compress because typically the gain reduces. We'll talk later, it could expand, but almost most systems, particularly if you're reaching a maximum voltage or a maximum power output, you tend to have it compress, meaning the gain gets less. And so in this region, we've got a nice linear power gain. Here, we're starting to compress and starting to get out of that linear region. And so we particularly take note when the output power drops 1 dB less than the expected value. So when this point is 1 dB below, that's sort of a metric where we say, at this input power, we're really leaving the linear range. And we call this point the 1 dB compression point. And it can be expressed as an input or an output. And what do I mean by that is I can say the input 1 dB point, compression point, is a certain value, and the output is a certain value. And those two are related.